So we have got a lot to get through today, so we'll be moving quite quick. There will be code up on screen. It'll be Python code. Feel free to take photos if you like, but the slide decks will be made available to you after this event. So as we go through, I want you to keep in the back of your mind what is the machine learning problem that you can help solve and that you can talk to your Amazon account team about. Machine learning is fantastic, but we need to identify a problem. It could be medical imaging, could be predictive maintenance, perhaps damage assessments from images, recommendation engines and fraud detection and so on. So today we're going to look at the Amazon machine learning stack. Now we can't look at everything in the stack, so we're going to focus on a handful of the application services. And we're also going to look at, and these services are pre-trained models, so you just interact with them via an API. But what we're also going to do is look at SageMaker, and this is an easy way if you need to build your own model. And we are going to build a model which detects whether people on a worksite are compliant with worksite safety, if they're wearing a hard hat. We're going to deploy that to a deep lens. We're going to use Greengrass running Lambda on that deep lens to perform inference, and we're going to output that inference to IoT. So, first of all, as developers, here's the first use case I'm going to give you. This is the problem I want you to solve. Given a photo, and in this case I'm giving you a photo of Andy Jassy, the CEO of AWS, and a large corpus of images, find every image that Andy Jassy is in. So in this case we've got one image. So I've run this through recognition images, and it's come back and said that it's found Andy in that second photo and it's 98% confident he's there. So how much code does it take to do this? So in Python, here's the full code. And really the key here is, once we've declared an object of type recognition, I pass in the source image, the target image, and what threshold I want to match at. I'm taking the response with the greatest similarity match, the greatest confidence, and then just printing that out. So what could you use this for? What use cases? So obviously looking for missing persons and wanted persons. Recognition already knows about celebrities, so it can identify celebrities in images. This is very useful to media companies. But it does so much more. So recognition can look for objects and scenes. It can filter out adult content, and recently it's also added extracting text. Let's look at a more complicated scenario. So in this case, I want to extract Andy Jassy. I want to find Andy Jassy. Is he in this video? But not just is he there, what timestamps do you find him at in close-up? So with a little bit of post-processing, recognition has told me that Andy Jassy has been found between the 14-second mark and 18-second mark, 26 and 40-second mark, and so on. Let's have a look and see how it goes.
Ladies and gentlemen.
Okay, so now I'm scrolling forward. So scroll forward to the 14-second mark, and Andy should come into close-up. There we go. That's the 14-second mark. Okay, now I'm going to move forward to the 18-second mark, and there we go, back into the distance, so we don't pick him up at that distance. Let's scroll forward to the 26-second mark, and he should come into close-up. There we go. Okay. So that's pretty powerful. I'm sure you can start to think of some great use cases, whether it's just your home videos at home or whether you're a large media company. This is the code it takes to do it. So the first thing we do after declaring our recognition object is to create a collection. Now, I'm only putting one person in my collection, Andy Jassy, but you can have multiple people. And then I call the start face search method. Now, this runs asynchronously, so I can put an SNS topic in that notification channel and receive a notification when the job's done, or I can just poll the job. So once I get, what I need to do is find out the job ID, which I could poll, but also once it's finished, I can pass that job ID in to the get face search method to pull my results. Now this returns me quite a lot of data, so it could be paginated, so it may be tokenized. What I'm doing here is just for each person, only one in my case, Andy Jassy, walking through and pulling out all the timestamps. Now, as I said, it could be paginated, and if it is, I just pass a token back in to get the next series of data. So again, use cases very similar, but in this case we've got temporal information. So we could look for activity in scenes. And obviously we could do automatic highlight extraction, find all videos with this, or create a highlight of all sections of the video with this person in it. All right, here's the next use case as developers. I want you, based only on text, so not the 5-star rating this person's given this shoe on Amazon.com, but only on text, tell me the sentiment of that text. So I'm going to use comprehend. Now I've just passed this text in, and you as humans can read this text and see some very positive language. And indeed, Comprehend has said that it's 99% confident that this is of positive sentiment. That's good. But what about this review? This person didn't like it at all. However, there's some positive language. I was so excited, cute little retro pump. So there's some positive language there. As humans, I'm sure you can read that and see that's obviously negative sentiment. And indeed, if we run this through Comprehend, it comes back and says, yep, negative sentiment, and it's 74% confident in this case. So, how much text? How much code? This is it. In fact, you don't even need this much. The line I've got highlighted here is detecting the dominant language. If you already knew it was English, you wouldn't even need to do this. So we've picked out that it's English, and then what we're going to do is pass that into the detect sentiment method. So we pass our text in and the dominant language and pull out our sentiment. Now I'm running this synchronously. This can also run asynchronously over a vast corpus of documents. So use cases. It's all well and good to monitor your internal systems. What about monitoring what people think of your company externally? So sentiment analysis of external feeds. But also Comprehend can identify dominant language. It can pull out named entities, and it can identify key topics. Okay, this is incredibly powerful if you want to automatically tag content, tag posts, tag questions, or so on. And once you've got all that information, it makes for a much richer search capability on documents. All right, last use case in the application stack, so transcribe. So same video as before, but this time, as developers, I want you to create a transcription of this clip. So I've run this through transcribe, and I've got the exact output below. So let's have a look at how it goes.
Ladies and gentlemen, please welcome Chief Executive Officer of Amazon Web Services, Andy Jassy.
So now we've got some music, not getting confused by the music.
Thank you, and welcome to the 6th annual AWS reInvent. This is our very favorite time of the year. It's our favorite week, and we're really excited that you're spending the week with us. You're here with 43,000.
Okay, thanks, Andy. So I think that did a fantastic job. Now, how much code is required to do this, though? Because that's a big use case. So here we go, again, Python. So I'm declaring an object of type transcribe, and I'm using the Sydney region. Came out a few weeks ago. Using the method start transcription job. So we just pass in our job and the media format. Now in this case, I'm going to poll. So I'm just polling for completion. And once that is completed, I get returned a signed S3 URL. So what I do with that URL, I'm just using the request package and pulling the information from it. And that contains a vast amount of information, not just the raw transcription that I'm pulling, but it'll actually contain different people who were talking. It'll recognize different people. It'll tell you exactly which position in your file, what is the timestamp of where each word occurred. So you could use this for a vast number of use cases. Obviously transcription, customer service calls. Does anybody here like taking minutes? Anybody? I hate it. So this would be great. Also generating subtitles on videos. So we're already seeing customers take advantage of this, and that's automatic. And once you've got this information about video and audio, this text-based information, perhaps run it through Comprehend and pull out your entities and key topics, enable far richer search. Okay, that's the application stack. What about if you as a developer need to train your own model? So like me, I wanted to train a model to detect hard hats. You've got this job now. How are you going to do it? Well, to make this a lot easier for people getting started, but also a lot easier for really experienced machine learning practitioners, to make machine learning so much simpler and to take away all the heavy lifting, we brought in Amazon SageMaker. There are some great talks about Amazon SageMaker, giving you full details of this. You can find one by me recorded from Sydney Summit if you'd like to go watch those. If you watch those talks, you'll find out about the 3 key areas of SageMaker, where we provide managed notebooks to help you with data exploration, where we provide a whole bunch of algorithms and also an easy way to bring your own algorithms to do training and distributed training, even hyperparameter optimization. You'll also hear about how we have single-click or single-line of code hosting, which will give you an endpoint, an auto-scaling cluster behind that endpoint, and it can do A/B testing for you. So as we said, SageMaker provides an end-to-end machine learning platform. I love this tool. I just love it. It is fantastic. But of course, you don't need to use all of it. You can use 1, 2, or all 3 of those components. There is no lock-in. There is nothing for you to set up. We handle all the setup of clustering. So not just standing up instances, but the networking for distributed training. If you don't want to use our built-in algorithms, we've got a whole lot of built-in frameworks, and you can hook into those and bring your own algorithm. Or if you want to bring your own framework, bring it as a Docker container, and you pay by the second. So let's look at the built-in algorithms in SageMaker. So there's a vast amount of these. There's unsupervised algorithms for clustering and so on. We've got forecasting, classification algorithms. Image processing, we're going to look at one of those today, which is the image classification algorithm. We've got built-in algorithms for natural language processing and anomaly detection. And there's always more coming. So here's the use case, developers. This is your job. Go and build a model where we can point a web camera at a building site, and it will find if people are being compliant with worksite safety, if someone has their hard hat on or not. So what's the first thing you're going to need to do? The first thing you'll do is select an algorithm. Actually, the first thing you'll do is decide to use SageMaker. But after that, the first thing you'll do is select an algorithm. Now, we've got an object detection and an image classification, both of which would work. I'm going to use the image classification in this case. The next thing you'll need to do is collect a lot of images. I collected about 2,500 images and did a mirror of every image, so I've got just over 5,000 images. And I'll show you some of them. I decided in the end, after a bit of trial and error, to use 4 classes. I've got compliant, hard hat, not compliant, no hard hat, or hard hat here. Unsure, perhaps we can't see the head, and no subject, there's no one in shot. I'll just show you 2. So this is compliant and not compliant, and here's just a handful of images. So find a whole lot of friends, colleagues, family, customers, and get a whole corpus of images, because this is what we're going to train with. I've even got my son there. So get a whole lot of images so this is compliant and not compliant. Some people have a lot of fun with this, as you can see. The next thing you're going to need to do is put those images into a format required by your algorithm. Now, the image classification algorithm I'm using is MXNet under the covers. So I'm going to put this into record.io format, which is the preferred format of MXNet. So the first thing you'll do, you can do this on your laptop, you can do it in a Jupyter notebook, and within SageMaker you could do it on an AMI, is create a folder. I've called mine images, and create a subdirectory under each of those for each of your categories. So you can see I've got the 4 categories, and that's where you put all your images in. Mine are just in JPEGs. The next thing we need to do is use a tool called Im2Rec, image2record.io. You can download that tool from GitHub, or if you've got MXNet installed, it's already there. So I had MXNet installed, so this is where it's located. What we do is we create a list file. This is how we do it. Actually, we're creating 2 files. Do you see that training ratio 0.95? What that's doing is it's creating 2 files. One file called training, which has 95% of my images, and one called validation, which has the other 5. So when I provide these to my algorithm, it will train using 95%, and then it will make an assessment of how accurate it is using the final 5%. So we create a list. It's prefixed with hard hat 224. You'll find out why in a tick. And it's going through the images folder. And the next thing we need to do is get a line count of that. See how many images we've got, because that comes into play a bit later. Now, what I've realised is, I jumped forward a bit there, I didn't give you a demo. You want to see this in action, don't you? All right. My wonderful colleague Mike has volunteered to be the subject here. Mike, would you mind coming on stage? Could we perhaps flick to the camera feed?
Hi, Jenny. Hi, everyone.
Hi, Mike. Let's have a look at Mike. So Mike is being very naughty at the moment. Mike is on a building site and he is not compliant. So we should be raising some alerts on this. Mike, could you put the hard hat, maybe just put it under your arm so we can see a hard hat? There's a hard hat in shot, but good, Mike is still not compliant. Mike, could you put the hard hat on? Very good. Thank you, Mike. You're now. Can you maybe turn around a bit? Yep, hands up, that's good. Face backwards. Excellent. Could you take the hard hat off while facing backwards? Not compliant, excellent. Now, some of you, thank you very much, Mike, thank you.
No
If you
worries.
don't,
Thank you.
I might get you to come back later, Mike. You might have noticed a couple of times there it did flick to not compliant. I just want to call out that this model was not trained under these lighting conditions. It's really important when you train your model to consider the lighting conditions it's going to make inference under. However, I think that's doing an excellent job. So I do apologise, I got a bit excited there. Thank you so much, Mike. Can we go back to the slides, please? Okay, so we've created a list file. Go have a look at this. It's a text file. Have a look and you'll understand exactly what's going on. It's a list of all your images. So once you've got that list file, we can now put it into rec.io format. We use the same tool, im2rec.py. Now here's where, see that 224? So I'm specifying a size, 224. So this means the maximum of length or width will be scaled down so that that maximum is 224 and scaled appropriately, 224 pixels. And depending on what use case you've got and how much resolution you need, you might use bigger or smaller. I found 224 more than enough for me. You can specify quality threads, specify the prefix and the folders images. So this, for my 5,000 images running on my MacBook, took about 10 minutes to run. Now we've got our rec.io files. I'm going to load them up to an S3 bucket in different directories, and this allows me to point an algorithm at them from SageMaker. Now what I'm also doing is I'm uploading some JPEG images, which are also scaled to 224. And the reason for this is before I download my model to the deep lens here, I'm going to use SageMaker to run some inference and locally and see how it goes. All right, so here we go. If we wouldn't mind clicking into SageMaker, and I'm just going to give you a bit of a run through, because I want this to be totally demystified. I want you all to go home tonight and use SageMaker. So the first thing you'll do when you go into SageMaker, I'm running out of North Virginia because my deep lens is running out of there, but you can run out of Sydney. So I'm going to create a notebook, give it a name, dev day, and pick a size. I find T2 medium usually fine for most of the things. And create a notebook. So you see that's pending, that'll take 2 or 3 minutes. And then you'll be able to click on, like my notebook here, you'll be able to click on open. So let's open an existing notebook. Now we've got a whole lot of built-in algorithms, but also we've got a whole lot of sample notebooks which use those algorithms. Oh, this is a bit small. Let's make this a bit bigger, actually. How's that? Okay, so see this SageMaker examples? Super cool. A whole lot of sample notebooks. What I did is I used this Introduction to Amazon Algorithms, Image Classification Transfer Learning, and you can click on Use. If you click on that, create a copy, it's going to create a copy in the root of your notebook. I'll just scroll out a bit, and there it is. So I'm not going to go through this one, I'm going to go through my notebook, but I'm going to highlight where I've changed this one, and really I've hardly changed anything at all. So if I go back to the root of my notebook, yes, I'll leave that. You can see I've now got a folder called Image Classification. That's the copy of the one I just made a copy, and if you do the same, you'll see that folder. So I've already done that before. Here's my notebook, and what I'm going to do is run you through the changes upon that base notebook that I've made. Let's make this a lot bigger. Okay, so the first thing I do is provide an S3 bucket, and this is the bucket where I uploaded those images to before. It's also the location where SageMaker is going to put my output model, my model artifact, which I'm going to download to this little thing. Now, you'll notice also I specify an algorithm type, image classification. This says to SageMaker, load up the Docker container from the EC2 container registry, Elastic Container Registry that contains that algorithm. SageMaker makes a lot of use of Docker. Here's some instructions. Notebooks are great for providing instructions. Now, hyperparameters. So, the number of layers of our neural network. So I've specified 18. If I had a lot more images, I could use a deeper network and get value out of that. I've only got 5,000 images, which is really pretty small. The image shape. Okay, this is really important. This determines how many neurons are in the input layer of our neural network. Three channels, red, green, blue. I'm using color. 224 by 224 is the maximum size that an image could be feeding into my neural network. Remember before we did a line count of our training list? That was because we need to specify the number of training samples. And the number of classes. This determines the number of neurons in the output layer of my network. 4 neurons, 4 classifications, compliant, not compliant, unsure, and no subject. I haven't changed the others, but you can look what they do. One thing I do want to highlight is epochs. So epochs in machine learning means the number of times you iterate over the data set. The reason I highlight this is because that will change the suffix on your model artifact. When you load it into the deep lens, we need to optimize it. We need to tell it what the file suffix will be. So just take note of that, okay? 2, just remember that. Okay, so other parameters. So we've set our hyperparameters. Now we need to set up training. Give it a job name. I'm specifying the output location. So I'm using that S3 bucket. I'm just specifying a folder called output. How do I want to run? Well, I've only got 5,000 images, so there's no point doing distributed training, and I actually don't have my limits lifted either. But if you've got more limits and you've got a lot more images, running distributed training, change that from 1 to a 2, 3, or 4, or something, as many as you want. That is huge. Distributed training is so hard. That is so easy. Specify the instance type you're going to run on. I'm impatient, so I'm going to run on a great big whopping 16XL. Okay, 2 channels, my training channel and my validation channel. Remember that training channel with 95% of my images? So all I'm going to do is specify the location where I put that file. My validation file with 5% of the images, specify the location of that. And run create training job. That's it. So that took, how long did this take when I ran it? It took about, there we go, 6 minutes to run for 5,000 images. So at this point, we've got a model. We can go and load that onto our deep lens. Or, if you're like me, you might want to test it a bit first locally. So what I'm going to do is I'm going to use my notebook to actually run inference upon that model, which means what I need to do is invoke a SageMaker version of that model. So give it a name. So this is the model name as it's going to run in SageMaker. That is the only change I've made. Give it an instance type. So a small instance is fine for me. It'll run on that instance type and it'll start with 1. And of course, SageMaker handles autoscaling for you, so if load goes up, it'll increase. Again, only change I've made on the sample notebook. And now we run create endpoint. I've made no changes here. Just create the endpoint. And we start a waiter here, run a waiter. So this took about 8 minutes or so to run. Okay, so now I've got an endpoint. I'm going to run inference against that endpoint. Now, it does take time to set these things up, so my endpoint's already running. So what I need to do is create a local client of type runtime SageMaker so I can run inference. Download those test images, remember those JPEGs? Download those to my notebook, and let's run some. So here's a picture of my colleague Jackie facing backwards. Let's run this cell. Scroll down. Okay, there's Jackie facing backwards, compliant, and it's 94.8% sure. Okay, I'm pretty happy. Okay, that looks good. Let's run my colleague Jonathan. So he's facing forwards and he's got his hand in the way. Let me scroll down. Here we go. Facing forwards with his hand up, and it said compliant, 99.9% sure. Excellent. Okay, this cell, run. Okay, this is Paul Migliorini, who you saw in the keynote. So yep, he's got his hard hat on, he's compliant. What about Mark, my colleague Mark? So Mark is, oh, naughty Mark. So he's in the office without his hard hat on. Not compliant, 99.9. I'm pretty happy. Lastly, I'm just going to pass in a wall, picture of a wall. So this should say no subject, run this cell, and what have we got? Come on, scroll down. Here we go. No subject, 99. Okay, good. All right, I'm pretty happy with SageMaker. So pretty happy with my model, I should say. So I've got my model. I want to download it onto this little baby. So what I need to do now is write a little Lambda function, which will invoke inference. Again, I'm taking the sample from Deep Lens, and I'm only going to highlight to you what I've changed or items of particular interest. Oops. Okay, here's the Lambda function. Where's the interesting parts? Haven't changed anything. Okay, I've created an output map. So if I get inference of 0, I want some text compliant, because I'm going to write it up on screen. Not compliant, so on. I've created a color map, because if inference is 0, I want to use green text. If inference is 1, I use red text. Okay, we optimize. This runs the Intel chipset, so I want to optimize my model to run on Intel using their CLDNN framework. Why can't I scroll? Here we go. And when I specify that model, see that epoch? Remember I said the number of epochs? And the only reason is because it changes the suffix on my file. That could catch you out, so there you go. Going to run it on the GPU. What else is interesting? Okay, we run a loop, get a frame from the camera, resize it down to 224 by 224 because that's the size of my model. Run inference, parse the result, get the top 4 result. I've only got 4, but anyway, get the top 4. Determine my output text and my output color from those color maps and output maps, and put the text onto that frame. So I'm preparing my frame, so I'm using OpenCV, prepare my frame, put my text in particular font, in the color I've selected, size and so on, and then display it, okay? So fantastic. Oh, and by the way, we're also going to publish to an IoT topic, so we'll publish inference to an IoT topic. So, let's deploy it. Deep Lens. So, Deep Lens. In Deep Lens, you have devices. So I've only got one. Sorry, that's projects. Devices. I've got one. Here's my Deep Lens. Device settings, it's online, nice. Notice it's got an MQTT topic. That's the IoT topic I'm publishing to. So, models. Let's have a look at a model. So we created a model in SageMaker, remember? Let's import it. Straight from SageMaker. How easy is that? Let's get the latest model. Give it a name. Latest. Now, remember, this was trained using MXNet. We do support other frameworks as well. Import that model. Okay, so I've got a model. Once I've got my model, I create a project. Let's create a new project. Now, we've got some samples here, you know, hot dogs and so on. But I'm going to create a blank one. So, dev day. I add a model, which was that latest. Yep. Add a Lambda function, which is the one we just looked at. I'll grab the latest version. It's got hooks to SageMaker. It's got hooks to Lambda. Add my function. Create a project. Got my project. Deploy. Select my device. Do I really want to replace my current project with this new project? Actually, I don't, because mine's running fine, but that's how you do it, deploy. Okay, now at this point, I just want to go, so I've deployed my model. It takes about, it depends on your internet bandwidth that this is connected to. Mike, could I borrow you, please, again? Thank you. So we can also subscribe to our IoT topic, as I've done below here. So let's have a look at inference coming out on our IoT topic. Okay. So Mike's being naughty without his hard hat. And as you can see, not compliant's pretty high. That's pretty close to 1, actually. Mike, could you put your hard hat on? Give it time. Here we go. It's dropped down, and look, compliance popped up. So you can imagine subscribing to this topic, and that's how you send alerts, notifications, perhaps send something to Mike's phone saying, put your hard hat on, please, and so on. Thanks very much, Mike.
All right. Can we build it, Jenny?
I think we can. Can you build it? Could we go back to the slides, please? So we've seen that the Deep Lens, it takes in a feed, that goes out to a straight device stream, but also we can invoke a Lambda function and run inference against a model. We can write to an IoT topic, and we can output to a project stream, which is what you were watching before. So as I went through this, what lessons did I learn? Well, I learned that you don't need huge images. In fact, 224 by 224 is probably more than enough. I originally started with compliant, not compliant. I realized over time it was good to add those other two, unsure and no subject. The optimized Intel model, and if you do multiple epochs, pass that in. You need to do that. The Deep Lens it has a micro HDMI output. I found it really useful to plug in directly, so you might want to buy yourself a micro HDMI to HDMI cable. You can never have enough images. I want to retrain this with stickers on the hard hat, with hands all over the hard hat, where the head's not visible. I actually did do that, and more from behind. Image augmentation, such as doing a mirror flip, helps too, and you can use image augmentation to perhaps do different lighting and contrast conditions, which I probably should have done. How can we help you? Talk to your Amazon team. If you had your badge scanned, or if you haven't scanned it, you'll get access to some links which will show you how to do what I've just done. If this is the sort of thing you want to see more of, please give us feedback and let us know. Thank you very much.